In this episode of niSCIdea, chemists in the US and Germany have worked together to develop a new method for the desalination of water, a discovery that may just hold the key for solving the world's freshwater problems. We all know how precious fresh water is, but the problem is that demand for fresh water is rising faster than supply. Of the 326 million trillion gallons of water on Earth, only 3% is freshwater, and only 0.03% occurs in rivers and lakes, the source that humans rely on most. The UN estimates that 1/3 of the world's population lives in areas without access to enough fresh water. That's 2.3 billion people struggling to find enough water each day. Because 97% of the world's water is salt water, a good solution to this problem would be to remove the salt from seawater. Sounds easy, right? Wrong. This is much harder than it sounds. Current desalination techniques aren't a good option because they require too much energy, and this just puts more stress on the environment. But chemists in the US and Germany have developed a new desalination technique that is relatively simple and requires much less energy. It's called electrochemically mediated desalination, or EMD. In salt water, the sodium chloride molecules separate into sodium and chloride ions, but it's the chloride ions that are the key to EMD. The researchers filled a small device with salt water. The device contains a microchannel with two branches. At the junction of these two branches is an electrode to which a small voltage of 3 volts is applied. This causes those chloride ions to pair up and be neutralized. This in turn creates an ion depletion zone that changes the electrical field at that point compared to the rest of the channel. The change in electric field pushes the salt into one branch while the desalinated water passes into the other. Imagine that the ion depletion zone is like Gandalf, blocking the path of the salt molecules while allowing the water to pass through. The method is so simple that it can even run on a store-bought battery. The major challenge from here will be to scale the process up. At the moment, the microchannels can only produce about 40 nanolitres of fresh water per minute. To be practical, it would have to produce litres of water per day. If this is successful, the technology could be used at different scales to meet different needs. Heard of some really cool science research? Let me know in the comments or on Facebook or Twitter. Don't forget to subscribe for more weekly updates from the world of science research.